All right. Good evening, everybody. I'm Michelle Stein, and on behalf of Protect Our Waterways, No Nuclear Waste, I'd like to welcome everybody this evening. Protect Our Waterways is a group dedicated to protecting our community from the NWMO'S desire to bury all of Canada's nuclear waste in an experimental radioactive mine beneath our farmland, river, and aquifers. We are asking the real questions. What happens if this affects the quality or the quantity of our aquifers? What happens to the 130,000 gallons of groundwater they estimate they will be pumping out of the mine daily into mine dewatering settling ponds once decommissioning and starts and the pumps are turned off? What does this possibility of new types of reactors being designed mean in terms of the type of radioactive waste that could be brought here? What does the newest report that suggests the amount of waste might grow from 5.2 million bundles to 7.2 million bundles because of the possibility of those new reactors? Are they going to need even more land? And what is the actual plan for monitoring at the DGR, besides the NWMO stating they plan to monitor? Why, after 18 years, is there no definition or method to determine willingness? How can the NWMO insist we must be informed before a decision can be made when they don't have the answers and they continue to adapt and change the plan to suit their goals? Protect Our Waterways is committed to keep calling on council to give each and every resident a voice in the form of a paper ballot referendum. We are going to continue to provide the information and reports about the risks and the unanswered questions. We're very excited this evening to have some international speakers. We welcome Dr. Johan Swan from Sweden, who has graciously agreed to get up in the middle of the night to share tonight, and Judy, who will be sharing her story from Nevada. And thank you, Bill and Bernane, for organizing another great webinar.
Great, thank you, Michelle. Our first speaker is Judy Treichel. We're very fortunate, as Michelle has said, to have two very experienced and knowledgeable speakers. Judy has been the executive director of the Nevada Nuclear Waste Task Force since 1987 and has been really a leading force in the critique and the opposition of the Yucca Mountain project. She has worked with the state of Nevada to provide education and promote citizen involvement in the review of that now halted project. Judy.
Okay, thank you very much for inviting me to be here. In 1983, the U.S. started looking for a spot to put a nuclear waste repository, and they were looking all over the country at many, many places. And in each place where they went, they were met with great opposition. So finally, in 1987, just 4 years later, the government decided that they would just select Yucca Mountain in Nevada, and they started site characterization. And the people of Nevada were very upset about that, but there was no choice that they were given. It was just that they started into site characterization. And they did that until the year 2002. Then they felt that they knew enough about the Yucca Mountain site that they recommended that it be built as a repository, and the Congress and the president agreed. And as soon as that happened, the state of Nevada filed a veto of that decision, but it was overridden by the federal government, and they began to prepare a license application. And in 2008, they submitted the license application to the Nuclear Regulatory Commission. By 2010, it was obvious that the state of Nevada was going to fight in every way that they could in order to thwart this plan. And so the Obama administration ended the funding and tried to withdraw the license application from the Nuclear Regulatory Commission. States that had nuclear waste got very upset because the Nuclear Regulatory Commission stopped processing the license application, and they went to court to sue the government because they had waste, they wanted to get rid of it. And the court decided in their favor and said that licensing should begin again, but only if there were funds in order to do it, because they couldn't order the government to do something that it had no money to do. So here we are in the year 2021. It's been 34 years. $14 billion has been spent. There is no repository. There's a hole in the side of a mountain out in the middle of Nevada. And the public has tremendous distrust in the government because they saw what went on with Nevada, and there's been a lot of publicity about the fact that Nevada was totally opposed to this, but it went on anyway. And one of the reasons that Nevada was chosen was because there was this thought by some people that Nevadans would be okay with having a nuclear waste repository since we had experienced atomic weapons testing. But that was kind of an idiotic reason to do that, because although Nevadans didn't say too much about it, when nuclear weapons testing started, there were only about 50,000 people in southern Nevada where the Nevada test site was. And at this point, there's over 2 million people here now. So Nevada's experience was a very unpleasant one, because bombs were tested above ground, below ground, over 1,000 tests were done. And the result was that people and animals living downwind were damaged. Many people died. Some ranches were put out of business. It was a real mess. And now there's contamination above ground, below ground at the old Nevada test site. And I'm sure it'll never be cleaned up, because I think what they're going to do is just keep it a restricted area for ever and ever. And the Nevada test site is on the boundary of Yucca Mountain. And for people in Canada, it's easy to explain what Yucca Mountain looks like. It's a long ridge that's there, and it's there as a result of a huge volcano that went off, had numerous eruptions, and Yucca Mountain is the result of that. And it's like a snowdrift. If you have a blizzard or a major snowstorm and there's wind, it'll create a snowdrift. And Yucca Mountain is a ridge that's sort of like that. The ash from the volcano just stacked up to make this ridge, and that was the site that they chose. I think earthquakes generally go along with volcanoes, and that area is very seismically active as well. Nevada is the third most earthquake-prone state in the United States. And in 1992, there was a 5.6 magnitude earthquake on the Nevada test site, very close to Yucca Mountain, and it wound up damaging some of the buildings that are there. And I know that in many places it's said that with proposed repositories, I think I've heard Grenade say this about the Canadian site, that it's not a question of if it will leak, but when. And that's what we've said about Yucca Mountain as well. And the repository would be above the water table, and as water came down through the mountain from rainfall or melting snow, it would contact the waste packages, and eventually they would corrode, and the radionuclides would be taken down by the water flow to a very valuable aquifer that is down gradient from Yucca Mountain, and it's the site of the largest dairy in the state, as well as other agriculture and a community of people who live there and depend upon that water. Also in Nevada, our economy is heavily dependent upon tourism, conventions, and visitors. And of course, Las Vegas is known throughout the world. And in fact, when people are asked if they've ever been to Nevada, there are some people that will say, no, I've never visited Nevada, but they will say that they've been to Las Vegas. So Nevada is dependent upon its income from Las Vegas. And as I said, the people in Nevada strongly have opposed the selection of Yucca Mountain ever since before it was selected. In Nevada, when people are running for office and they have to run statewide, they will always tell everybody in the audience that they are the most opposed to the Yucca Mountain project. They will be the one that, if elected, will finally kill the project. And it's very frustrating for us because the project never was killed. It just, the government just quit funding it. So we have to sit here being at the ready with technical experts, with attorneys, all of us keeping watch in case some administration would decide that they're going to throw some money in there and they will restart this in order to get a repository going if there's not another project started. So our efforts right now are to get this thing stopped. Nothing has happened on it for 10 years. There's no department even existing anymore in the government for the development of a repository. So it's just Nevada that's sitting here staying ready for anything that might come along. And many studies have been done by the government, by some colleges, by other groups about what should the U.S. do in order to take care of nuclear waste. And almost all of them, or I guess all of them that I'm familiar with, have agreed that it's got to be a consent-based process. And so right now, what we're looking at is, what does consent mean? We know that it's not what we dealt with, where they selected a site and then thought they could convince the people that it was a good idea, but who would be the ones that would need to consent? And if you consent, can you then withdraw if things aren't the way that you thought that they would be? Or how would all of the process work? Would it be fair? Would it deserve your trust and confidence? And those are the things that have to be answered before there's any kind of a new project in the US. And one of the things we worry about is the fact that $14 billion has been spent on this process. And so they believe that it would be bad to walk away from that kind of an investment, but it's probably going to cost more to do Yucca Mountain than it would to be able to do any of the other sites that they may choose if they were able to find one where people consented, they were willing to work along with it, and there wasn't going to be just a battle started before any of the work ever got going. So those are the kinds of things that we're looking at right now. And we're kind of in a position where we know everything that can be done wrong. We're not too sure how it would be done right. And I'm not sure that it can be done right. It's very difficult to go and look and see a place, regardless if it's granite or the result of a volcano or salt or clay or whatever, and know how it's going to work a million years later or several 100,000 years later, after it's had a lot of site characterization done, where you've essentially opened the thing up. You've allowed air in there, you've done a lot to change it, so it's not the kind of site that you initially looked at. And one of the things that is very troublesome for public interest groups here in the US is, if there's a repository site found and if the government puts out the word that we're ready to go, this is a great site, everything's going to work, then is the next statement that comes out, okay, now we can make more waste. We can start up with small modular reactors. We can use nuclear technology a lot more because we finally have answered the waste problem. And we're very worried about that because we don't want a waste repository to mean that you have more waste generation. I think the United States is a great example, being able to look back on it now, of always putting the cart before the horse. We produced the waste before we ever knew what to do with it. Yucca Mountain was designed, and the license application is for a site that's designed around a particular container that they would put inside that would meet specifications, but those containers were never built. They don't exist. The waste that's at the repository sites right now is sitting in huge containers, because you get more bang for the buck that way. If you put in a huge canister, you can put a lot more waste in it, and you save money rather than getting a lot of smaller containers to put the waste in. And right now, as I said, they're looking at small modular reactors, but there's no thought to be given to what would happen with the waste that those produce either. And so they are looking at centralized interim storage in the United States, and we oppose that because it really wouldn't make the public a lot safer from the waste. It would just strictly have the waste on the roads and moving around. It would move it away from the reactors, but it wouldn't dispose of the waste. And so the places that are being looked at now as possible sites for centralized interim storage are very concerned about that. And we are as well. I don't like the idea of centralized interim storage, but I especially don't like the idea that it can be called interim, since Nevada is the only spot on the map that's been considered for waste repository. So if you're going to call something temporary or interim, you have to be able to say when it's going to leave and where it's going to go when it leaves. And right now, we're just about the only target. So the entire program in the U.S. really needs to have people step back, take a big breath, get some better radiation standards, take a look at how you would have a successful consent-based program, and start again at a time when we can take all of the lessons that we've been able to learn over more than 30 years and put those into play. And I think that's all I've got to say, unless there are questions later. Bernane, you're muted.
Thank you very much, Judy. That was really insightful, very helpful. Our next speaker is Dr. Johan Swan. Johan is the director of MKG, which is the Swedish NGO office for nuclear waste review. It's the envy of the NGOs in Canada that this coalition was established, I think 12 to 15 years ago. Johan can correct me on that, for the purpose of having public interest interventions, public interest participation in the review of the Swedish Deep Geological Repository proposal. And Dr. Swan is also leads the radioactive waste management work of the European organization Nuclear Transparency Watch, and is a member of the International Panel on Fissile Materials. So we're thrilled to have you here tonight. Johan, please go ahead, and I think you'd like to share your slides.
Yes, thank you very much, Bernane. It's very nice, good for you to invite me, and I'm very happy to be here. Is the sound okay like this?
It's very good, thank you.
Okay, then I would share the slides. So, okay, so my name is Johan Swan, and I have been working for a long time with nuclear waste issues. I was actually at the University of Chalmers, University of Technology in Göteborg for many years, and did a PhD there on policy issues regarding spent fuel repositories. MKG is a society that is created with the Swedish Society for Nature Conservation, Naturskyddsföreningen, which is the largest Swedish environmental NGO. They have over 200,000 members, and also the Friends of the Earth are part of MKG. As Bernane said, MKG was created in actually 2005, and at that time, the government actually decided to not only resource the communities that were intended, that were planned for repositories, but also the Swedish environmental movement could apply for funding. And we were able to then to create a small organization There were actually two of them created. One is also called Milkas, but MKG has been the larger of the two, and we have been working since then, basically, with the spent fuel repository problems in Sweden, and also there are also, of course, other repository projects that we've been working with. So see if I can get the next slide. There we go. And I will just give a very short introduction about the background for the Swedish nuclear industry's plan for a repository for spent nuclear fuel, and then I will do a short background on the licensing process that's been ongoing for quite some time now. For well, it's actually pretty much 10 years since the application was given in by the industry. Very importantly, there was a decision by the Swedish Environmental Court and the Swedish regulator in January 2018 with recommendations to the government, because it's now a government decision. It's actually a very, very intense discussion in Sweden about the government's decision making on the repository. But what was important was that the court decided to recommend to the government to say no to the repository, because at least until certain issues with the copper canister were resolved. And I will also say something about the government review of copper corrosion issues that's ongoing. And also quite an unexpected development, because there were new experimental packages from an old project in the hard rock laboratory in Sweden that were retrieved. And they have 20 years of copper corrosion in them. And there was quite a lot of copper corrosion there, unexpected amounts of copper corrosion. I will also make a short note on Finland, because the Finnish project is very similar to the Swedish one, and they have a very different decision-making process. So they are actually now moving ahead, even while Sweden is hesitating on this issue. So the KBS method, basically, this is also the Canadian method. It's the UK method. It's the method that is foreseen to be used, I think, by many countries if the Swedish and Finnish governments approve, or it started to be used in Sweden and Finland. There are different capsulation concepts, but most of them had copper, a complete copper canister like the Swedish one to start with. I know that the Canadian one now is a steel canister with a thinner copper on it, which is also very strange for us. But the method was developed in Sweden in the 70s, and in 1983 the KBS-3 report came out, and the idea is to go down about 500 meters underground in the granite bedrock, and there are tunnels here. And in the tunnels, there will be holes drilled down, and then the canisters, which includes then the spent fuel, it will be surrounded by bentonite clay. And the clay will also fill the tunnels and the whole system, and all the way up until maybe about halfway, when they will be undecided yet exactly how they will close the whole repository system. So the long-term safety case of this kind of system relies on the artificial engineered barriers, that is the copper canister and the clay around it. And the clay buffer is supposed to protect the canister from the water in the surrounding bedrock. And the king of the system is actually then the copper canister, which is supposed to protect and isolate to protect us for hundreds of thousands of years. And in 2009, the nuclear industry chose the Forsmark nuclear power plant as a site for the planned repository. I'm going to back up. So I need to talk a bit about the siting situation, the Swedish siting situation was very, very problematic, like in all countries, I would say, like in the UK, like in Canada, and it failed several times. But finally, they decided to focus on communities that had nuclear power. So 2 sites were chosen right by the nuclear power plants in Forsmark, which is north of Stockholm on the coast, and down in the southeast coast of Sweden, where Oskarshamn nuclear power plant is. And these 2 communities were extremely bombarded with propaganda about how safe the repository was going to be. And they have managed somehow to integrate themselves, the company, which is a private company, even though many people believe it's like it's a state public company. They integrated themselves very, very much into the communities, and they have actually now got between 70 and 80% of the community people in favor of the repository. And so the Forsmark, the Östhammar community has about a year and a half ago, has said yes to the repository, because they have a veto basically, but they did not want to use the veto. They said they accepted the repository, and actually now trying to pressure the government to make a decision as fast as possible. So let's go back to the method. There were 3 actually reports, the KBS, KB1 and 2 and 3. We were doing reprocessing work in the 70s, or reprocessing was planned for Sweden, which was then abandoned. So the KBS 3 method is for spent fuel direct disposal. So the development was 75 to 83. Here are the 3 reports in all. And what happened, of course, since the early 80s is that there's been a lot of development of the method. So this is from one wall in the office that we have, and these are the reports here. And actually on top here are the applications for licensing. So it's a huge material, both the research and all the reports. Of course, this is not, the number of reports is not important if there are big problems with something. I also said there that we started to work in 2005. So we have been following all these reports and studying them for a long time. Now, the nuclear waste company submitted a license application to build the spent fuel repository using this method at the Forsmark nuclear power plant on March 16, 2011. And we have 2 legislations in Sweden. One is the Nuclear Activities Act, and this is the regulatory act where the Swedish Radiation Safety Authority work and does its work to study like the safety case and other things. But we also in Sweden have an environmental code, and we have an environmental court system where all projects that can have harm to the environment have to be licensed also according to the environmental code. Not all cases are taken to the government, but important environmental cases are not left to the court and the regulator to decide, but the final decision has to be taken by the government. So the initial review for completeness took 4 years. Then the application was announced formally to be complete, and during 2016, 2017, the application was reviewed on issues, and there were extremely many issues covered. I mean, the Forsmark site is not a very good site for many reasons. There are problems of different types, and of course things like intrusion problems and so on, and many issues were covered. And but the main issue that became apparent already in 2007, it had actually been already a problem discussed in the 80s and 90s, but we did not even know about this when we were almost surprised by the copper corrosion issue surfacing. And there are especially researchers at the Royal Institute of Technology in Stockholm that have done research and show that copper corrodes in this environment, the repository environment, in much greater rates than SKB has been claiming. So it was quite good because we could also support the researchers who did not have, let's say, experience regarding how to work in the system with legislation and so on. So the license application is huge. It's very big, thousands and thousands of pages. And our briefs are not as thick, but we did produce 12 briefs in the period between 2012 and 2017, and we've been producing briefs to the court. And also now we are working towards the government and sending them statements regarding different issues. So what happens in the environmental court is that, first of all, of course, the court has to decide that the application is complete enough to be announced formally, to be then reviewed on issues. And after the review on issues, which basically means that we are sending our issues, and SKB is responding, and we are sending the issues, and SKB is responding. And this is done not only, of course, by the environmental movement, but also by the communities and by other actors, including the Swedish Council for Nuclear Waste, which I will come back to. It's the Swedish government's advisory board, and has also played an important part in promoting, giving a fora for discussions for the council. So the whole process in the environmental court system finishes off with a main meeting of the court. And here at the main meeting of the court, the regulator, they did tell the court that there could be some copper corrosion issues, but they felt that they could be dealt with after the government decision. And the court questioned this very strongly at the meeting, because the regulator, SSM, they should be following also the environmental code, because that's stipulated within the Nuclear Activities Act. It says that they should follow the main intentions of the environmental code. So there was a big controversy between the regulator and the court at the main meeting of the court. So this, especially that the court said, they have the environmental code says has to be shown that it's safe before a government decision, while regulator, has been saying, well, perhaps there are issues that can be dealt with afterwards. But also in the court, there were very eminent scientists from the Royal Institute of Technology, and they strongly questioned the SKB position on copper corrosion. Now, the whole main meeting of the court took place over a period of 5 weeks. And we were 2 weeks in Stockholm, then 1 week in Östhammar, 1 week in Oskarshamn, and then 1 week in Stockholm. And a whole extra day was spent just to talk about copper corrosion. But also during the court proceedings, there were leaks to the media showing that the regulator, SSM, had big internal problems. The corrosion expert was against a positive decision. And also it was shown that there were SSM scenarios that regulatory limits would be exceeded in certain scenarios. Now, this apparently there were people within the regulator that were leaking out information. So this is a picture from the main meeting of the court. To the left, actually, here you see the lawyers of SKB, and behind us now is actually the court itself. there are two. It was a double court because it was such a big case that they doubled the number of judges and experts for the court also. And down here is our team, and these two people. This is me, and this is my colleagues at MKG, and these two persons are Rebecca and Lucia, and they are environmental lawyers for the Swedish Society for Nature Conservation. And I would say they are very excellent environmental lawyers at that organization. So the cooperation between MKG and Naturskyddsföreningen was quite successful, has been quite successful. And this is an article that was then it's saying that there were problems with SSM. So after the court ended the main meeting of the court, they retired into the chambers, and they came up with a recommendation to the government on January 23rd, 2018, as I said in the beginning. And the court recommended that the government said no to the application, primarily because of the uncertainties regarding the long-tail safety of the planned repository due to possible copper kinetics problems. And these issues, the court said, had to be resolved before a government decision. But on the same date, the regulator, SSM, told the government that it could say yes, as some issues could be dealt with later after the government decision. And the regulator also believes that the repository can be safe even if the copper kinetics does not work properly, as the other barriers of the clay and the rock. Now, this decision took many Swedish people by the surprise, and it actually can be seen as a very important victory for science and for those who have raised this issue. Now, what is the problem with copper? Basically, there is the hypothesis that oxygen-free water does not corrode copper in a repository where there's no oxygen after closure. And that this hypothesis is false. So basically, the idea is that when you close the repository, the copper is consumed very fast. We know this now. And after the oxygen is consumed, there should be no reaction, so that copper should be like gold in the repository conditions. And of course, in the air, I don't know how many copper roofs you have on the buildings in Canada, but copper was used historically very much in Sweden. It still is to a certain extent as a roof covering, and there you have the greening of the copper. So when the oxygen is actually attacking the copper, and even though it's better than other materials, it still corrodes the copper in oxygen. Now, what the scientists have been saying is that water can actually corrode copper even when there's no oxygen. So the water molecule is split on the surface of the copper. And then it's the same process that the oxides are formed, the copper oxides are formed, these green and black the surface is corroded. And actually, what the scientists are saying is that the repository rates may be very much faster than acceptable, because it's also very hot. The copper surfaces are about 90 degrees, and corrosion increases with temperature rapidly. So they were saying it could take maybe less than 1,000 years instead of 100,000 years or 1,000,000 years until its release of radioactivity. And we also saw in 2017 the results of copper corrosion in a Swiss experiment that was 18-year-old copper in clay underground in an experiment. And there you had quite deep corrosion and pitting corrosion, which is like in a car where you start corrosion, it continues at the place and it goes very much faster, which is of course a very big problem if you have a canister and the corrosion goes deeper and deeper and deeper in the points where it started. So there's the ongoing review of the copper corrosion issue by the government. The nuclear waste company made a submission of complementary information on copper corrosion in April 2019. And what I can say about that is that basically nothing very much new came into it. So it did not really satisfy the court's demand for more information. It was basically much more of the same information, and the criticism of the company of the court, and they said basically that the court did not have the competency to deal with these issues. But we are quite certain that the court both saw that there could be problems and also saw that the regulator maybe was not doing its work properly. So we provided our comments to these extra information from SKB, and so did the regulator and others. But the regulator was convinced that the repository, the new information, its conviction that the repository would be safe was strengthened by the new SKB information. Now, the Swedish Council for Nuclear Waste, I mentioned it before. It's the Swedish government's scientific advisory committee council, and they also have copper corrosion experts, and they have lots of experts in different fields, and they also have been saying that there may be problems with the copper, even though they are not completely in agreement with the critics from the Royal Institute of Technology. But they also say there might be a problem with the cast iron insert, and this is kind of a new discussion going on between the council and the regulator. So we have made strong statements to the government saying that they should not use copper as a canister material. And what has happened then is that, and the researchers at KTH, they've also pursued criticism, and now they've been joined by the SSM corrosion expert that I mentioned before, that was opposed to SSM saying yes. Now, I'm going to spend a few minutes, final minutes basically, on describing some new interesting developments, because there is a project called LOOT that we knew about for a long time, and we have seen for a long time that the LOOT project could be very important. It's a project that's been ongoing at 400 meters depth at the Espe Hard Rock Laboratory. It's close to the Oskarshamn nuclear power plant, and they started about year 2000. There are 7 experimental packages with copper and clay in a very good simulation of real repository conditions. Now, 3 one-year packages were retrieved very early, and then SKB retrieved a 5-year package in 2006, and it was basically they had difficulties in reporting this because there was so much copper corrosion that they, it took them some time to write the report, and when the report came out, it was really very, very brief regarding the copper corrosion. This meant that we understood that the other 4 packages could be very important, and we have demanded for a very long time that the next package should be retrieved and analyzed. So this is the experiment, basically. If you look here, you have a man standing. It's about 4 meters long, and there is a copper tube here. So it's not a full-scale canister system, but it's quite good anyway, because there's a copper tube here, and then there's clay around the copper, and then there are copper pieces here that were specifically made for studying corrosion in the clay. But also, of course, the copper tube is important because it's heated down here at the bottom. So this is the hottest part of the copper tube, is about here, and also the whole system stands on a copper plate down here. And I will come back to this. So the copper coupons are here. Here is some pictures from the retrieval of some new packages that came up, and here is the copper coupon, and here is the copper tube. Actually, this part here is the hot part, and we haven't seen any pictures of the hot part. We've only seen pictures of the cold part, and I'll come back to that. So in the autumn of 2019, SKB, they secretly retrieved two now 20-year-old packages, and this was because they had in a research program promised for a very, very long time that they should be taking it up soon, and they couldn't wait any longer. So in 2019, they took them up. This was disclosed by SKB, likely as a mistake, at the meeting organized by the regulator in the beginning of October of 2019. Actually, I asked a question to an SKB representative about the project, and I think she made a mistake by actually admitting that it had been retrieved. But then we started to pressure that this information has to become available to the government about how much corrosion has taken place. And also we wanted the SSM, the regulator, to check the results. And this actually then developed, so it happened. And SKB promised, first of all, not only to disclose the results, but also to disclose the results of the tube, because the last time they did not do that. They did not discuss the copper corrosion of the copper tube, only of the coupons. And the results came in October 2020, and SSM has been doing a quality assurance project, and it's actually finished. And I will come back to what the assurance project came up with. So we have told the government that they have to wait for the results, and because if the corrosion is as bad as the PEBEX experiment, you remember the other pictures we saw from the PEBEX experiment, something is very wrong with using copper as canister material. And this is wrong. SSM has made a statement of the loot results in March. Now, this is the report that came out in October 2020. And here you see the corrosion of the bottom plate, and it's quite intense, the corrosion. Some of this material is sand that is caught in the copper corrosion products, because the bottom plate was standing towards sand and wasn't connected to clay. And here is a picture of the tube. Now, this is the picture of the tube, and you see similar pitting corrosion going on in the tube in this part. But the problem is that SKB only published pictures of the tube here. And if you look at the temperature here, you see it's very much hotter down at this point. And here SKB refused to make any kind of these kind of metallographical pictures, or even show pictures of the surface of the copper. And they also refused to make any studies of the bottom plate. So we stated very clearly that this was not a scientific report, because if they had done it scientifically, they would certainly examine the most corroded parts and show how much corrosion has been going on here. And the big discussion is whether the corrosion that is taking place in this, they say, in this area could be due to trapped oxygen. And we are pretty much convinced that there was not very much trapped oxygen at all, because in the start of the experiment, water that was taken out of the tunnel wall was pumped in to the whole, to fill the whole system, and that water was anoxic, without oxygen to start with. So we are quite convinced that there is a big problem with corrosion here. What has happened? Okay. I will just have to take this. I think I'm missing a picture, but that don't worry. So what has happened is that the regulator SSM, they did a big project to study the quality of this work, and we provided them 4 different sets of input, and also the researchers at KTH provided the regulator with the information that they thought was relevant. Now, they also used external experts from a UK company called Galson Sciences. And the Gulf Sciences experts were quite good, actually, because they said that there could be problems here. There could be alternative explanation for the one that SKB had. But in the end, basically, the regulator and the consultants and the regulators said that if everything is like SKB says it is, then everything is like SKB says it is. And then the regulator, unfortunately, they went to the government and said that they thought there was no new information coming out of this experiment. But we are very upset about the regulator here, and it's quite problematic that the regulator is working so close to SKB and only accepting the information from SKB. So at the moment, the government has a very big problem because they have to take a decision, and it's difficult for them to take a decision against the opinion of the regulator. And this is perhaps where the Swedish Council for Nuclear Waste can come in, because hopefully the government can perhaps initiate a process to get more information out of the LUT experiment and to get that information that should be scientifically accurate. So the situation is quite difficult here at the moment, and there also politics has started to get into the process. We have a green social democratic government, and the Greens have control over the Ministry of Environment, and they are kind of negative and they understand these problems. But the opposition parties that are more right-wing, they are now pressuring the government, and the industry is pressuring the government, and the local communities are pressuring the government to take a decision. So finally, a few words about Finland, because Finland was sending its spent fuel rods. They also have nuclear power, and they were sending the spent fuel rods to Russia for reprocessing. And then that was stopped. And actually, they had a very good contract. They did not even get any high-level waste back from Russia. But when that was stopped, then they started a process of copying the Swedish KBS method. And the decision-making on environmental issues is very different culturally. Also, the country is different regarding environmental issues, I would say. And the project is seen more like a technical project than an environmental project. So the Swedish government decided very early in this century that a repository should be ready in the early 2020s. And since then, decisions have been taken with this time frame in mind. And there is now a construction license for the Onkalo. The project is called Onkalo, near the Olkiluoto nuclear power plant. And the construction has reached the repository depth, and they've actually started also now with tunneling for the deposition tunnels. And they have constructed an encapsulation plant on top of the repository at the surface, and that should be done or finished by next year, actually, the encapsulation plant. So they hope to be able to get permit maybe by 2025 to start to deposit canisters. But they also, of course, need I think they will also wait out a Swedish repository decision. I think I don't know if they will dare to go ahead with if the Swedish government has not said yes to the repository system. So we have a website, of course, mkg.se, and there is also an English part on that website. We try to update it as much as possible, but we have a lot of things to do in Sweden, and if you really wanted to see what's happening, you can perhaps use Google Translate to translate the Swedish website to see the latest developments. So that is what I would like to say. So thank you very much.
Great, thank you very much, Johan. That was excellent. Just an excellent overview. And we got lots of questions, lots of interest, and we'll work through them now. I think that we'll maybe go back and forth between Judy and Johan, although I think our first question is actually it would be interesting to hear comment from both of you. So the question is from Simon, and he asks, why globally do we consider deep geological repositories when none are operating globally? This is a real concern, but yes, this is a viable, we're told this is a viable option by governments in Canada, for example. So in Canada, certainly we're told it's an international consensus. So if Judy and Johan would both comment on that.
The National Academy of Sciences here in the U.S. did an examination of that a long time ago, I think in the 50s, and decided that deep geologic disposal, because it would be considered to be unreachable, so you wouldn't have human intrusion into the site, and without knowing anything about the underground, it always looks good. So the more they learn, the more problems there seem to be. And at one point there was talk about deep sea disposal, where you would go under the deepest part of the sediments in the ocean. And I don't know if anybody's ever given that enough study to know if it would be as problematic as on land has proven to be, but you run into international problems with that too. And I would guess that there would be a huge pushback against using any sort of ocean disposal.
Great, thanks, Judy. Johan, what's your view on how they've stuck this claim of an international consensus on deep geological repositories in the absence of an operating repository?
Well, I think that somehow it of course comes natural to think that if you can bury something deep, perhaps you can make it safe. I mean, you move it away from society and nature as far as you can. I think in the Swedish case, the 500 meters decision, which I think also has influenced a lot of other projects, that 300, 500 meters depth is where you're supposed to go. It was basically because that's where we have lots of mines in Sweden. We have been going down to 500 meters depth for a very long time, even going back to the 19th and even even earlier. We have been doing mines to those depths. And it's true, like Judith says, that the intrusion could be less, of course, if you go deeper. But we are still very concerned about intrusion problems for the long term. You also have the question of the plutonium in the spent fuel that will be like a weapons material for 100,000 years also. So there are environmental problems, there are security problems, and it's even though, of course, the international community, like the International Atomic Energy Agency or OECD, they put out this information, or the European Union also, that this is like a consensus that this is how it's supposed to be done. It's quite a lot of happy talk in that sense. It's basically, it hasn't been shown yet that it can be done anywhere. Sweden and Finland are working with granite, so are other countries like Canada. There are some projects that are working with clay, and the French project is the most advanced one, that have clay instead as the material. But we aren't there. I mean, they aren't there yet, and I would very much, we should avoid 500 meters depth systems at all, I think. Yeah.
Thank you. The next question is from Johanna, and some of these questions, I'll say, Johan, might be expect you to be more familiar with the Canadian program than I think it's fair of us to expect you to be, but I'll pose the questions. Are the canisters similar in Canada to the canisters that are designed for Sweden? I believe they're also using copper here. So if you could just comment on similarities or differences to the degree you're familiar with the Canadian program between SKB and the Nuclear Waste Management Organization's current concept.
Yes, they are similar, and actually, if you go back a while, you'll find that I think you will find the copper canister thicknesses which are the same if you go back into the concept, the Canadian concept earlier. Now the Canadian concept is actually a thinner copper with steel underneath. And in the Swedish concept, the cast iron insert that you have inside the copper surface, 5 centimeters copper surface, is supposed to be the mechanical integrity. Of course, the steel integrity becomes bigger but the copper surface of 3 millimeters, as I understand you are having, if the copper for 5 centimeters will break down in 1,000 years, 3 millimeters will be nothing. And the problem is that at 3 millimeters, as soon as you have a crack going down to steel, because the steel is more corrosive than the copper, at least, it will also corrode steel much faster. So I don't really understand this idea of only 3 millimeters of copper. I think it's almost like they're going the other way from the Swedish system, that they give it even more importance to the copper than we do.
Great, thank you. A question for Judy. Judy, do you feel that Nevada is already stigmatized, at least in the minds of the public outside Nevada, by the nuclear weapons testing that was done in the 50s and 60s? And David also mentions the untold number of nuclear horror movies, almost always located in Nevada. So Judy, what do you think the role of the stigmatization as results of the nuclear testing might have played in Nevada being targeted?
I don't think it was really that we were stigmatized with that. It was the fact that there was a feeling that Nevadans had agreed with the idea of weapons testing here. And at that time, when it started up, I think that was the main employer. And so when you had people working at the test site, they believed in what they were doing. It was thought to be a patriotic sort of thing. And if people were asked today if we could develop new nuclear weapons and we could come back to the Nevada test site and test those out, you'd have a huge outcry, which would be no. And the fact that a nuclear waste or a nuclear waste site at Yucca Mountain or the Nevada test site would affect transportation through Las Vegas and through other major, all of our railroads and highways go through major metropolitan areas. That's why they were built, was to connect cities. So you've got really big transportation problems, but I doubt that many people in the US remember nuclear weapons testing.
Great, thank you, Judy. A question from Sandy for Johan. Could Dr. Swan elaborate on specifically how the proposed NWMO DGR might differ from the SKB design? Are any design changes indicate absolutely no precedent if even the well-known Swedish concept is not being proposed by the NWMO? So maybe if you could, Johan, just a comment on any differences that you're familiar with between the SKB approach and the NWMO current concept.
Yes, I think I already mentioned this, that it's not a complete copper. It's steel and then the copper surroundings. I mean, we have also seen some discussions that one should use only steel. And the KTH expert from the Institute of Technology, they say that the best steel is much better than copper. Now, the problem is that the best steel will not work for 100,000 years. So we would need to have something like gold to have a repository in this granite system where you have all this water flowing around, which can attack the canister. But otherwise, the Canadian system is very similar. And the Canadian scientists that have been developing canister in Canada are cooperating with the Swedish scientists that SKB are using, or rather not the Swedish scientists, but the SKB scientists, I would say. Also, there are scientists in the UK which have been working on copper issues also, but the copper corrosion studies done in Canada show very clearly that the Canadian system is also looking at the copper as the material to provide the main safety for the canister.
Great, thank you. I wonder if you could comment, there's a couple of other sort of design differences. Canada, the NWMO has opted to use a vertical shaft rather than the ramp that we see in other jurisdictions. And they've also opted for an in-room placement rather than the 1992 option was a borehole, in-floor borehole, looks similar to the SKB. Can you comment at all on SKB's rationale for selecting in-floor boreholes versus in-room, or for selecting ramp versus vertical shaft?
Yes, if you look at the Swedish concepts, there was the idea of having a vertical hole with an elevator, and there still is that, for personnel and so on in the Swedish system. The Finns are using an elevator system, a shaft system. So they're building the encapsulation plant right on top of the repository, and there is going to be a big elevator to send down the canisters, but they are very big and very heavy. And in the Swedish system, that the canisters will be loaded onto a special truck that takes them down the ramp. And I think that they are thinking that it's possibly better to have control over the access by having a ramp like this. Regarding the question of having holes in the floors compared to having vertical deposition on the sides of the tunnels, there have been studies in Finland and Sweden also about using the horizontal disposal in the tunnels. Perhaps if they started with that, they might have been using it, but they did not develop them enough for the applications. And because it's a different process, they had to make a decision at one time, and then they decided, both of them, to go for the holes in the floor. The French system I spoke to you about with the clay formations, they will make holes in the sides of the tunnel and then push in the waste packages into holes in the side of the tunnels instead.
Great, thank you. A question from Kevin. You had mentioned human intrusion risk at the Swedish facility. Can you speak a little bit more about that intrusion risk? And Kevin also asked about the risk of sea level rise at both Sweden and Finland.
Yes, and Kevin also asked about mining projects in Sweden. I answered that one by writing. Yes, there are mining projects in Sweden. We have iron ore mines in north of Sweden, and they go down to below 1,000 meters, down below a kilometer, those mines. So you understand that the technology to make this repository is still existing. And the problem with that is, of course, that in the future, people can go down to 500 meters. And as I was saying before, we had the technology to go down to those depths in Sweden already in the 19th and even in the 18th century. We have mines down to 300, 400 meters, actually in the area of Forsmark, because it's a very historic mining area. There's no mining going on at this time, but it used to be, and you have open shafts there down to 300-400 meters in that area. So this is a long-term problem with the repositories at these depths, that people can go down there, and also they can find the shafts, or they can find the tunnels to go down there. And this is discussed very much now, because how do we inform the future? I know that you have Dr. Gordon Edwards in Canada, and he's been discussing very much the question of not putting the the waste down and then just abandoning it, because you cannot do that. But you need to have a surveillance of the waste for the long term. And when this is now being discussed, both on a national and international level, you realize how difficult this will be to inform the future about the dangers of the repository. And you can have all these scenarios for this long term, 1,000 years, 10,000 years, what will happen. And then I'm quite certain that the problem of having radioactivity come out of these repository systems at these depths from human intrusion, intentional or unintentional, is much more problematic than these safety case analysis of how much corrodes and those. So the main problem, I think, is actually intrusion problems and not the problem of the canisters. But that's difficult to discuss because it's so inherent in these systems that people don't really want to discuss this problem. And Gordon has also seen this problem. I think that people do not want to discuss this. That you have to have a surveillance and some sort of active also I talked about the question of the non-proliferation, nuclear weapon proliferation problem. That's also long term. Actually, that is what I wrote my thesis on in '92, about this problem of the nuclear explosives predicament, the long term nuclear explosive predicament. Regarding the climate issues, well, this is basically the repository is supposed to be safe for ice ages, because glaciation, I think of course you have the same situation in Canada. The safety case has to be made for ice ages, because that is what is normally been expected, that there will be 1 or 2 ice ages within 100,000 years. I guess that the climate change may not provide that problem. We may not have so many ice ages in the future. On the other hand, you have the constant problem of sea level rising, and in Sweden actually we have also a land rising at the same time, so we don't really have that problem. I guess also in Canada you are quite far away from the I don't know what altitudes you are compared to sea levels, but you probably are a bit higher than the Forsmark site, for example. But the Forsmark site is still rising. The rock is still rising from the decompression of the last ice age. But still, the Forsmark site will be underwater in about 1,000 years from now. But of course, it's supposed to be sealed, and it's the safety case according to SKB, and it's supposed to be manageable.
Great, thank you. A question for Judy from Johanna. Judy, what are your thoughts on, Johanna would like to know what you think disposal is the answer in a different location, a deep geological repository in a different location. You did say that you weren't comfortable with centralized long-term storage. So what are your thoughts around the best options for the medium to long-term management of nuclear fuel waste?
Well, we have discussed this a great deal amongst grassroots groups and public interest groups, and our consensus generally is that you're best off leaving it as close as possible to the point of generation, because the more you transport the waste, the more you're opening up the possibility for accidents. And if you're just taking it somewhere in order to free up a spot for for more waste, you're increasing the size of the problem. So until you really have a spot that you know is a one-way trip, our opinion has been that would be the one trip that you would make, and up until that time the waste would stay where it is. And I know that it's problematic at some places, and so that's why we always say as close as safely possible, because most plants were built near waterways, whether it was near the ocean or near rivers or whatever. And so if you're sitting there on the sand dunes, obviously that waste needs to be moved to a safer place, but should not be taken across the country, with the idea that perhaps at some point you'd have a disposal site back on the other side of the country.
Great, thank you. And a question from Kathleen. Kathleen's asking around temperature, and she says there was a mention of temperature speeding corrosion. This is a question for Johan. If numerous bundles placed together within, and assuming bundles will be stacked, will this all collectively cause an increase in temperature and speed up corrosion? So I wonder, Johan, if you could just speak to that relationship between temperature, maybe even comment on how the proponents estimate temperature in repository at depth over time. And what's the relationship between temperature and corrosion?
Well, the exact relationship is different for the different materials and so on, but it's almost exponential in a sense with rising temperatures. And many of the experiments that have been done in repository conditions have been at quite cool temperatures. Now, the idea with the canisters is always to try to keep the temperature of the surrounding clay, which has water in it, below 100 degrees when it's boiling. And so, but still you want to be able to put the spent fuel into the canisters as soon as possible. But still the spent fuel has to wait maybe 30, 40 years before it's possible to put them in the canisters. So they are producing a lot of heat for a very long time. So it's a challenge to balance the age of the fuel rods that are put in each canister to keep the temperature, let's say at a maximum 90 degrees of the surface. But this will probably be the case for all these repositories, that they will be at these high temperatures of 90 degrees because you will want to operate them like as soon as possible and to get the spent fuel down into repositories. And this means that corrosion processes will be as fast as quite very fast in the systems. Also, they have been discussing problems because you have in the systems you will not have water immediately, perhaps at the surface of the canister. Likely you will at the bottom of the canister, so that it'll corrode very fast at the bottom. But at the top of the canisters you will have water vapor. And the water vapor will then condensate, and it will bring salts from the water and aggregate them on the copper surfaces, which will also increase the corrosion rates. Now, this corrosion also causes hydrogen to be released, and the hydrogen, especially if water corrodes copper, then the hydrogen goes into the copper and causes embrittlement of the copper. So there are a number of problematic corrosion and other problems for the canister, and I think that is why the corrosion experts that are independent from SKB are so concerned, because it's the total problem of all these processes that can cause the canisters to break so soon.
So, thanks. Go ahead, Johan.
No, I was just, what was the question?
Well, I think you answered it, but I put it away by then now, so I can't actually revisit it.
Okay.
You have a follow-up question, and that's a question around just given all this information around the analysis that identifies corrosion of copper as a problem, how likely is it that the companies, SKB and potentially even eventually NWMO, might propose a different material, possibly carbon fiber or other non-corrosive material? Is that, do you think, in the works or in the offing?
Well, the thing is that SKB and Posiva they will fight to the bitter end, because if they agree that copper is a problem and decide, well, we will try something else for a material, a canister material, they will have to start all over again. It's a very long process. But if you ask these corrosion experts at the Institute of Technology, they are looking at possible. I mean, even bronze actually is better than copper. So because bronze is more corrosion resistant than copper in these environments. And I think there was also a question in the Q&A about copper and how we can, with the pyramids, how they have only been there for so long, and how can we assure that this will work? There is actually a problem that there is very little copper available from artifacts from archaeology, because copper actually corrodes. We have a situation with the Vasa ship in Sweden, the Vasa ship that was sunk in the Stockholm harbor. If you come to Stockholm, there's a very nice museum with this ship. There they had bronze cannons. The bronze cannons, they would look pretty good, but there were also many copper coins, pure copper coins, with the sailors on the ship that sank. And those copper coins are completely corroded, as have other copper coins. So the pure copper has a problem compared to bronze, for example. So you will find many artifacts historically that are made out of bronze, but very few that are made out of copper. And if you find them from copper, it's because they have had very dry and also non-oxic environments that they have been in. It's quite complicated. The whole thing is quite complicated. You can also find pure copper, which is very, very old, because it has been inside rocks, also without any connection to air or water. And there you can break out there you get a pure million-year-old copper piece, but there's no relevance to the case of the repository, where there's water all the time. So I also want to comment. I saw somebody mention the Into Eternity film. If you are interested in this question of how to think about how to preserve information to the future, the Into Eternity film, it's a Danish director, and he's interviewed people both from Sweden, but mainly from Finland, from the Olkiluoto, technical people who clearly show that they just are hoping that everything will be okay in the future, basically.
Good summary.
Yeah.
We have some related questions from Kevin and from Doug around the role of money in the siting process, and I think we'll put this to both Judy and to Johan. So Doug asked what the role of bribery has been in terms of purchasing trust or consent. And Kevin asked what the financial incentive has been offered for the Swedish repository site. And didn't the site that lost the competition get a monetary reward as well? So maybe if both Johan and Judy could comment just on the role of financial incentives or compensation in the U.S. and the Swedish siting processes.
Can you start, Judy?
Okay, quite some time ago, they tried to get a monitored retrievable storage site going, and so they had a nuclear waste negotiator that was to go out to various locations and talk to some Native American tribes as well. And they would give so many $1,000s to have an initial study, and then if you stayed with it, you'd get a little more money and so forth. And they had a few takers, but it appeared that people were sort of playing the game until they saw the end of the money, and then they would opt out. But it's very important that you don't have a site where you claim to have consent, but yet you have very poor people who have few options, and they're going along with this because they feel it's the best they can do, that this would give us jobs or this would give us something else. What you really need to do, as far as having consent is concerned, is to have a community that's actually willing to work with this thing and be an active partner and be allowed to be an active partner, to be part of the studies, to have their own independent studies, and to be able to be part of setting the rules, part of setting the standards, where they're working in a partnership all the way along, and it isn't, we'll pay you to be quiet. I don't know how it would work, but I know that it's got to work as an equal partnership, or it's not what we would consider to be consent.
Great, thank you. Johan.
Yes, it's quite a complicated this issue of money and the communities, and also the environmental movement. The Swedish communities have also been have the possibility to get funding from the Nuclear Waste Fund, and that is where our organization also got money to start with. Now it's out of the state budget, but for a specific reason. But the community still gets the money from the Nuclear Waste Fund, and that money is to be used for the community to strengthen its possibility to work with these issues, to have their own experts and so on. And that kind of funding is I think, generally quite good, because it can improve the decision making with having allowing other actors also to have resources and being able to take in experts, and also to have even staff at the communities, and like MKG, we have people who can work full time on this, and I think that strengthens the decision making process. Now, there is another system in Sweden where, before the siting, decision was taken in 2009, an agreement was between the industry and the two communities of Oskarshamn and Östhammar, that they would get compensation if the repository was to be built, and that is kind of more bribery money directly. But that, in that case, the government is not involved at all, because the government controls the Nuclear Waste Fund money. Even though it's industry money that is put in the waste fund, the government controls that and decides who can get funding and for what. But this agreement, and it's true actually that it was agreed that the community that did not get the repository would get more money than the other community, but it's quite substantial amounts, on the order of, let's say, US dollar. It's about 300 million to share, US dollars. Or maybe 200 million. It's quite relevant, and that's supposed to be used for infrastructure and for different things. But also SKB has been putting in a lot of money into culture and sports and sponsors and so on. You know, to get this acceptance, they have become part of the society. And of course, in a nuclear community like Oskarshamn or Östhammar, where Forsmark is, they have a long tradition, and many people are employed within nuclear power plants and so on. So it's understandable that communities like this can have a larger acceptance than others. And of course, now the communities are actually pressuring the government to take a decision, and I think some of that is at least related to this compensation money that they will get once the decision is taken.
Right, thank you very much. We've got just 3 more questions, and I'm going to recommend to those who have not yet done so to open the chat box. There's lots of good information there and many links. And if you look in the lower right, you'll see 3 dots. If you click on those 3 dots, you're able to save the chat, so you can preserve those links and go back to them after the session has closed. So we've got 3 more questions. A question from David, and I think they're all for Johan. And it's getting very late in Sweden. So 3 more questions from David. Were there any variables or unknowns identified that may come from climate change that could affect the KBS method?
Well, I did mention before that climate change could be, you know, both affect the glaciation scenarios, but also that sea level rise can cause problems. But I would say that the sea level rise, it's still on the scale of 1,000 years from now, that Forsmark will be, in the worst case scenarios, that there will be water in Forsmark. So I don't think it's that important, perhaps. Maybe I have missed something, but it's not been a very important issue for us to deal with.
Right, thank you. And a question from Gordon, and you've touched on this already, but Gordon is noting that the Swedish Swedish design will use 300,000 tons of copper. And he's just raising again the issue of intrusion, and would that volume of copper be further incentive to recover and therefore intrude into the repository?
Yes, I've been looking for the exact weight of copper in each canister. There will be about 11,000, 6,000 canisters. They will weigh 25 tons each, but most of that is not copper. So I think that the estimate of 300,000 tons of copper is a bit high. Maybe that would be if you had a whole world's spent fuel in the same system. But it doesn't really matter, because copper might still be an attractive material to mine for a future society, certainly. So yes, that is problematic in a sense, that copper is valuable. But look at our society. In a sense, copper is getting to be less used in some areas and more used in some areas. And copper also, of course, there are problems with copper with regards to environment and also to human health, the use of copper. So of course, it's not clear that all societies in the future will see copper as a resource, but of course there will be some society in the future that will see copper as a resource, because these are very long time frames. So it's I agree with Gordon that it's important.
Great, thank you. And our final question, and then I'll invite Judy and Johan if they would like to make any final comments, anything they wish someone had asked them but didn't ask them, and then I'll turn it over to Bill Noel from Protect Our Waterways, No Nuclear Waste. So our final question is, I think for both, I think it's for Johan, just around the role of Indigenous peoples and feminists, and what kind of influence or role have they played in nuclear power and waste decision-making in Sweden and in Finland. Johan?
Because the Swedish nuclear power plants are in the south of Sweden and also along the coast of Sweden, there has not been much discussion regarding indigenous people. The Sami people in Sweden, they are mostly in the north of Sweden. However, the question of gender is important, I think, here, and we have a very, very strong, of course, as in many countries, a strong feminist movement, and they are also involved, actually, especially the green feminists are also involved in trying to influence this issue. Generally, women are more opposed to nuclear issues than men. Elderly men are more for nuclear issues than for nuclear power or accepts nuclear waste repositories, and young women are the least. You see this in different opinion polls. So there's certainly a gender issue here that is important.
In the U.S., you asked about Indigenous people, and it certainly is no surprise to anybody that Yucca Mountain is right in the middle of the Western Shoshone tribal lands, and they have had a battle going ever since that started, and they've been strong opponents to the Yucca Mountain site, and the storage, one of the centralized storage sites is also in New Mexico, where it would be have a strong effect on native lands as well. So that's been a problem. I would agree with Johan that people generally that I talk to, I don't know of any official poll, but I find that young women are less likely to go with nuclear power, whereas some of the older men who have been around for a long time and just got used to it, I guess, they are more for that kind of thing. And you find younger people being more opposed to nuclear weapons. And in this country, nuclear power and nuclear weapons have kind of gone hand to hand. They've sort of, they've propped each other up. And so that's a real problem. But you were talking about corrosion and avoiding corrosion, and the great idea in the United States, because they do realize there will be corrosion, was to have a nickel alloy for the container, and then each of the 11,000 containers would be covered with a surrounding titanium drip shield. So that would be a huge expense, and they plan to in place that 100 years after the waste has been in place, which is insane because you would have rockfall, you'd have degradation of the tunnels and all that sort of thing. So the entire U.S. Design and program is really riddled with a lot of problems. And I've been reading a lot about recently in Chernobyl, there's problems going on where it appears there's a criticality happening underneath the covered up waste. And there's always talk about, well, what if you had a lot of water that got into a repository after there had been corrosion? Could you have criticality? And the answer is yes. And I think the on again, off again readings that they're getting out of Chernobyl at this point look maybe a way of seeing that happening now.
Yes. Yeah. Final comments. First of all, I found the figure for how much copper is in each canister. It's a little over 7 tons. So that 6,000 canisters, that's about over 40,000 tons of copper. So you were not far from Gordon, and that's an enormous amount of copper, of course. But it's not very much if you look at the turnover per year of the global market of copper. Even 42,000 tons is not so much, especially if you're going to be depositing copper canisters over a period of 30, 40, 50 years. So it's not going to influence the copper price, for example, and as some people have been discussing. Now, what I can say is that when you're working with these issues, nuclear waste issues, it's an extremely frustrating situation because of the enormous resources available to the industry and the enormous amount of people they can employ and the scientists that they can pay and so on. It is a very tough fight, and I really am happy to see that you are doing very good work also, because it's important to us in Sweden to know that there is other people working in other countries and in the U.S. and everywhere. So I just wish you the best of luck, and hopefully we can get a successful development here regarding the government decision. But you know, it's a very uphill struggle that we are working with, and it's quite a heavy load that's upon us. Also, one should understand that even if the government decision is taken, it's going to take a long time before they can start to make any even start to work on the repository, because we will be appealing in courts. There are a number of possibilities to appeal in courts in different parts of the continuing process, because the environmental court will also have more meetings to discuss the conditions for a license and so on. So there will be 5 years more after the government decision of work, and I would probably be pensioned even during that time, before that time, but I'm sure there will be good Swedish environmentalists that will be working, trying to stop the project, because we're really very, very, very convinced that copper is a problem. When you see something like the loot experiment, where the industry just cannot even show what has been going on, then you know something is wrong. So we are very strengthened by that, and I think also there are other people who are hesitating because of this in Sweden also. So we'll see what happens. I think time is with us. The longer it goes, the more information will come out about copper and other issues. So thank you.
Well, thank you so much, and many thanks coming in through the chat. Judy, did you want to add a final comment, or shall I?
Well, I think this has been really worthwhile, and I hope that it's helped you. Thank you for putting it on. And I think we should all stay in contact with each other. The nuclear industry has a lot of, and the governments have a lot of connections internationally, and it's important that those of us who are working in various countries don't feel like we're the only ones fighting it. There's a huge amount of crossover with the problems that each one of us has, and I think I'm very grateful for internet technology that we can stay in touch with each other, and we should keep a lot of information flowing between us. But thank you.
Good. Thank you both very much, Judy and Johanna. Over to
one more comment.
Oh, certainly.
Johan, I have one more comment. I just realized that I was making the presentation for a UK group in February, and that is the one I showed you now by mistake instead of the one I prepared for you. That's why I was missing some slides, and I will provide you with the correct one that you can distribute also with the correct presentation. So there you will have a little more information about what is going on since February, because many things are happening. So thank you.
Well, thank you. It was an excellent presentation. So thank you so much. Over to you, Bill.
It helps if you turn on the mic. Well, Judy, thank you very much. I learned a lot tonight. I didn't know about the amount of experiments that were conducted on relative to the atomic bomb, but I also very much in tune with the fact that consent is a necessary thing and a very important thing. And if you discover something later in the process, that you're able to back out of that consent, I also believe is a very important dimension. We agree with you. We are, South Bruce is a community, and same with Ignace, the other location that is being considered by the NWMO. Both of us are in a really depressed community. We have no big economic growth, and our communities are shrinking. So it's always that people want to look at what we can do to improve the situation. And sometimes that gets solved because communities just say, well, I need to do this for whatever reason. And the environmental concerns sometimes get trumped by the economic gains that we're seeing forecasted for these types of projects. So Judy, thank you very much for enlightening us on those activities in the States, and then we do want to keep in touch. Johanna, your presentation was so full of technical details, and I learned so much more tonight about the whole issue of copper, but also the fact that I learned that, you know, your encapsulation plants or capability, which we call the repackaging here in Canada, they are co-located with the nuclear sites that exist. So transportation doesn't become a real issue at all for you, whereas here in Canada and as well as in the United States, the transportation issue will be one of the things that people worry about on going forward. This is, as you mentioned earlier, a tough fight. You know, I've only been involved with this since February 20th. 2020, and I can tell you I've learned so much more about the nuclear industry that I never thought I knew anything about it previously, and the whole issue of trying to solve this problem of the nuclear waste is a big issue for the nuclear industry, and they really are pushing hard to bury it in the ground and hoping they can abandon it and not think about it in the future. And that's not something that we think is a good idea. And we're fighting that to the best of our ability. So I want to thank both of you for being with us tonight. And hopefully we can keep in touch and keep informed about what's going on in each community. It's always nice to learn what else is going on in the other parts of the world. So thank you very much.
Thanks.
So with that, Bernane, I'll turn it back to you, and you're on mute.
Thank you
Thank
all,
you.
and we'll say good night, and we will send out follow up with the chat because we did see a number of people weren't able to save it. So we'll have some follow up in the next couple of weeks. Thanks so much. And thank you to Protect Our Waterways, No Nuclear Waste for hosting, and certainly
You're welcome.
and Judy for the excellent presentations. Good night all.
Good night.